Hello again everyone, welcome back to ptet.chemistry channel. So in this lecture tutorial, this is the third of a series of lecture tutorials on these year 9 concepts on getting the chemical formula of both ionic and covalent compounds. So yeah, if you haven't subscribed to the channel, if you found the channel and whatever it has to offer useful, please do subscribe to the channel, click the button on the bottom right and follow me on Instagram, Facebook and Twitter at ptet.chemistry. That is at ptet.chemistry. Subscribe and share the channel widely with all your friends, your various chat and study group or Discord group or whatever other groups you have, and yeah, your juniors and your seniors from school and anyone else you think who will find the channel useful. Phosphorus oxide, despite the name, you can think of valency. These are non-metal and non-metal. Phosphorus is non-metal, oxygen is non-metal as well. So we do not talk about ionic bond at all, but you can think of valency. I'm talking about valency. I'm not talking about charge. Be very careful, all right? So the combining power of phosphorus when they form covalent bond is 3 in this case because it's phosphorus 3, and then 2 for the oxygen when they share electrons, because these are valency, these are not charges, which is what we have done throughout this lecture tutorial. It's the same idea, so you also need to cross multiply because it's to do with the number of electron shared, not the number of electron lost again, but the number of electron shared. So it's 2 and 3. So the formula is P2O3. However, this is the simplest ratio of the atoms. This is actually called empirical formula. In fact, that is not how it actually looks like. It's actually P4O6, which is the molecular formula. We will touch more specifically on empirical and molecular formula when we come to that lecture tutorial. Okay, so P4O6, how does it look like? So you don't really need to know how to draw P4O6. I am just going to draw for you to show how it looks like. And of course, they can ask you in questions to try and count how many of the atoms you have. Okay, so here you have phosphorus forming 3 covalent bond. Each phosphorus form 3 covalent bond. Each oxygen forming 2 covalent bond. There are 4 phosphorus, 1, 2, 3, 4, and there are 6 oxygen, and there are however many bonds there are. That's P4O6. All right. However, you can either write P2 or 3, or you can write P4 or 6. This is empirical, which is simplest ratio of 4:6, divide by 2. You will talk about empirical formula as a definition that you must know for O-level or IGCSE chemistry later on. P4O6 is the molecular formula, how many atoms are actually present in one single molecule, because these are simple molecular structure. Okay. So I'm just going to quickly copy that. I will copy that because there's something important that I will show you in a little bit. So that is phosphorus oxide, and that's the simplest ratio of atoms. I think I can maybe copy all of that. Yep. So I've done all that. And that is for that thing there. And I also need to bring down my SiO2, which I don't want to leave up here. I'll just cut this one, and then I can paste it. Somewhere down there. So there's a silicon 4 oxide, SiO2, giant molecular. I just want to bring attention to something that was phosphorus 5 oxide. So here, this is phosphorus 3 oxide. Either P2O3 or P4O6, they mean the same thing, okay? When you have phosphorus 5 oxide, which was the Roman numeral 5 here, so what happened then is the valency, the valency on the phosphorus would be 5 there. So you will have 5. When you cross multiply, you get 5. So it's P2O5. Again, there's the simplest ratio. The molecular formula is actually P4O10. And it actually follows through from how P4O6 looks like. That's how P4O10 will look like. Because here, shown here is P4O6 from just now. The phosphorus can have more than 8 electrons in the outer shell. Because phosphorus is in the third period, the third period can go beyond 8 electrons in the outer shell. Because the third period is the third shell, it can actually accommodate up to 18 electrons. Here you have 2, 4, 6, 8 and 10, and that is still allowed because you haven't reached 18 electrons yet. This is phosphorus plus 5, 1, 2, 3, 4, 5. Just now you had phosphorus plus 3. I said phosphorus plus 3 because there's something called oxidation state, and the oxidation state of phosphorus is plus 3, but it is not ionic. Oxidation state is something you will cover either towards the end of your year 9 or the beginning of your year 10, and in a topic called redox changes. Alright, very quickly copy down, cut this thing which we did for phosphorus 5 oxide and move it down there, and I might have to continue the rest of this tutorial in the next series. Okay, let me just finish this one off, cut that, and see if I can get enough space or not. Not really, there's not enough space. I have to move this up a little bit. Don't want that. Move that up a little bit, and then I should have enough space now, I hope. Yeah, that should be alright. Okay, let me just draw like this so that there's a partition and it's nice and clear. Okay, so moving on. In fact, I don't think I should move on because I think this lecture tutorial has gone long enough. So I'll probably stop here for this part of the lecture tutorial. So moving on to the next example, sulfur dioxide. So sulfur and oxygen. So it's a di, meaning it's a 2-time oxygen, whereas the other one is a trioxide. So it's 3-time oxygen for trioxide. Sulfur and oxygen. 1 sulfur, 2 oxygen, 1 sulfur, 3 oxygen. These are very important compounds of sulfur that you will come across as you do environmental chemistry in another topic called nitrogen and sulfur. So SO2 looks like this. The oxygen form double covalent bond. The sulfur is in group 6. They form 1, 2, 3, 4 covalent bond. You still have 2 electrons left, and that would mean sulfur has 10 electrons because 2, 4, 6, 8, 10 electrons around sulfur, and that is okay because sulfur is a third period element. Just like phosphorus, it was okay because you're a third period element. You can have more than 8 electrons, but no more than 18 electrons in the third shell. SO3 is when you have another oxygen, it can form a double covalent bond with the sulfur so that you get SO3 like this. Now the sulfur has 2, 4, 6, 8, 10, 12 electrons around the sulfur, and that is still okay for the same reason as I outlined before. Lithium oxide. So the lithium is in group 1. You would have realized that we did sodium oxide. Potassium oxide will have similar formula, which is K plus. You need 2 of them to balance out the O2 minus charges. So just to recap on what we did in the last lecture tutorial. So you have, I've done a careless mistake. It's Li plus from group 1. So plus 1 minus 2. We cross multiply the value on the charges. This is a plus 1, so the value on the charge is 1. The value on the charge is 2. So it's 2. What that means, what that number mean is how many of these do you have? So you have 2 Li plus, so you have Li plus and Li plus, and you have 1 of O2 minus, so that would be Li2O, just like that. Okay, so let me just cut that and put it together with the bunch of formulas which we have here. Probably need an extra page there. Okay, Moving on to the next example. So we have chromium 3 oxide. Chromium is a transition metal. You will find it in the middle block of that periodic table. On the first row, there will be scandium, titanium, vanadium, chromium. It's a chromium 3, so it's Cr3 plus and an O2 minus. So just like in the previous example, we have in the previous lecture tutorial, we have aluminium oxide, Al3 plus O2 minus. So sometimes a lot of the time is based on experience and what you have done before, and you know when something has gone wrong, because if you know the formula of aluminium oxide, Al2O3, and you see something similar here, this means you have 2 of the chromium 3 plus and you have 3 of the O2 minus. You can see the plus 3 and plus 3 give you plus 6. Minus 2 minus 2 minus 2 is minus 6. The whole compound get balanced out if you have Cr2O3. Cr2O3. So that's Cr2O3 there. And I'll just very quickly just paste the working down there because I will need this PDF. Well, for my own students actually, whom I'm teaching. Okay. So phosphorus pentachloride, this is a chlorine and this is a phosphorus. So both of them are non-metals. You can see that there's going to be covalent bond. A phosphorus with 5 chlorine. As you could imagine, just like in the oxide in the previous question, you have Cl. You have phosphorus, Cl, Cl, Cl. So this is a single covalent bond, single and single. Phosphorus is in group 5. It's got 5 outer shell electrons. So what happened there is phosphorus still have 1 lone pair. So there is PCl3. Actually, there is phosphorus 3 chloride or phosphorus trichloride. And then phosphorus pentagon, 5-sided building in the US. So there's 5-sided building, and here you have 5 chlorine is pentachloride, PCl5 then. Carbon tetrachloride, again carbon and chlorine is going to form you covalent bond. Tetra refer to 4 times, and this is CCl4. Carbon form 4 bond. Each chlorine forms single covalent bond. The carbon therefore covalent bond. Each chlorine forms single covalent bond. Make sure that when you draw the dot and cross, these are not hydrogen. These are chlorine. So you still have 3 more lone pairs, meaning 6 more bonding electrons. 6 more electrons which are non-bonding. 6 more non-bonding electron, 6 more non-bonding electron, 6 more non-bonding electron there. Okay. Carbon dioxide, that's just CO2. Carbon disulfide, there's CS2. You can hopefully relate CO2 from the structure and bonding. And this is how CS2 looks like, because sulfur is just below oxygen in the periodic table. Okay. Moving on to the next one, we have potassium nitrate. This is the ITE. This is not the ATE. ITE is NO2 minus, and you have a K plus. Hope you can realize by now at this stage that you're more advanced. You can see the plus 1 cancel the minus 1. You actually get KNO2. If you really can't see it, I'm going to show it now. This is a plus 1 charge. This is a minus 1 charge for nitrite with the ITE. And then you will bring down the value. You bring down the value of plus 1. The value is 1. The value of minus 1 is 1. So what you have is K plus and NO2 minus. So altogether you have KNO2 as your formula there. Okay. So I think I better move that somewhere else because I think I'm running out of space here. Okay. Moving on, we have silver chloride. So earlier, I think in the last lecture tutorial actually, so silver as a compound is a silver plus 1, or you can say silver 1 like that. So what you have is Ag plus and soup. So I don't know why that happened. So what you have is Ag plus and Cl minus, which give you the 1-to-1 ratio. So that's just AgCl there. Okay, I hope that was quite straightforward for you. If you want, you can show it with the plus 1 and the minus 1, but it should be very straightforward at this stage for you. If you have not, I recommend you to actually rewatch the last lecture tutorial part 2 to get used to the idea. Bring down or cross multiply the value on the charges. The value on the charge is plus 2. Okay, what you bring down is the number. The value on the charge minus 2, the value is 2. This is not simplest ratio. What you want is the simplest ratio, whole number ratio of the ions. You can divide by 2 and that will give you 1. That will give you 1. 1:1 means 1 calcium 2 plus and 1 CO3 2 minus. You combine them, you get CaCO3, and that is the formula of calcium carbonate. Okay, carbonate is CO3 2 minus then. Now you have potassium manganate 7. So manganate 7 is this really tricky looking compound, well ion, sorry. MnO4 minus is one of the most important ions in the whole of O-level and IGCSE chemistry. You will use it a lot in practical studies. This is called manganate 7. You never ever forget the VII, which stands for 7. It's actually plus 7 because it's something you will learn in oxidation state as oxidation state in the redox topic later on. But you got to remember the value, the formula of the ion itself, alright? So it's a K plus and an MnO4 minus. So you have a plus 1 and a minus 1, which of course you can see they do get cancelled out easily. But I'll just show you the cross multiply, which is to bring down the value of the charge to the other side, the value of the charge to the other side. So you need 1 K plus and you need 1 MnO4 minus. Altogether your formula is KMnO4 for your for your formula. Okay, so I'll just bring that down, because otherwise I really run out of space there. I should also bring down the calcium carbonate one, which I shown you already earlier, that thing there. So keeping in mind that K plus and MnO4 minus, don't forget MnO4 minus. There are a few polyatomic ions that you can never ever forget. MnO4 minus, therefore with K plus you just get KMnO4. Sulfate, alright, so these are SO4 2 minus, SO4 2 minus. Should really probably not need to write there. What I can do is calcium 2 plus, SO4 2 minus. Plus 2 minus 2 should be very clear to you that the one of these will cancel out the charge because the charges are equal. But regardless, it's good to show you how it works. The value of this charge is just 2. And the value of the charge minus 2 is just 2. Simplest ratio 1:1, because 2:2 is not the simplest ratio. So 1:1 means 1 of calcium 2 plus, 1 of SO4 2 minus. So what you get is CaSO4. In terms of sodium sulfate, you have Na plus SO4 2 minus. So you have a plus 1 and a minus 2. Now these are different from these. They do not get cancelled out. You can do the cross multiply thing. You bring down the value of the charge, the number, which is 1. You bring down the value of the charge by crossing multiply to the other side. So what you have is Na plus and Na plus, and what you have is SO4 2 minus. So your formula is going to be 2 of the Na and 1 of the SO4. So there is Na2SO4, like that. Okay, phew, there's a lot of examples here. Sodium sulfite is SO3 2 minus, sulfate is SO4 2 minus, SO4 2 minus, sulfite is SO3 2 minus. So you can see that the formula of this and this is going to be the same as that, because you follow the charges. You do need 2 of the Na plus in order to balance out one of these. So the formula looks really similar, and one mistake, one I instead of A, would means there are difference of 1 oxygen, and they will mean all the difference in the world when you go into the lab. You could be killing someone if you get this wrong. Alright, methane is CH4, silane is SiH4. So carbon is above silicon in the periodic table. So carbon form 4 covalent bond like this. Silicon also form 4 covalent bonds just like that. This is silane. The one on the left is what you call methane. And yeah, The methane, silane, you can see from the similarity in the name, and hopefully it makes sense to you, some of these names, because it will have to become part of your vocabulary going forward in your O level as well as your IGCSE chemistry. Earlier on in the last lecture tutorial, I talked a lot on this hydroxide. We talked about it a lot earlier. OH minus. So you have copper 2 plus, OH minus, plus 2 minus 1. Bring down the value on the charges. So what you have is 1 of the copper 2 plus and 2 of the OH minus. So that you can see the formula is copper bracket OH twice, so meaning copper with 2 hydroxide. Mercury is in the transition metal, is the only mercury as a metal is the only liquid metal in the whole periodic table. Is one of 2 liquid. This is a metal. The other liquid is bromine at room temperature and pressure, but that is a non-metal. Hg2 plus and Cl minus. I really hope at this stage you can see is HgCl2, which of course if you can't, then you can show it using the long method. Do whatever it takes at this stage, but eventually you need to really be able to see that you need 2 of these to get the -2 overall to cancel out 1 of the Hg2 plus. Alright, on to the next one. I think that color is not great. Iron 2 plus, Fe, iron 2 plus, bromide, Br -1 because it's group 17. Well, sorry, group 7. 17 is what the A level students will use. So bring down the value on the charges. So I need 1 of that, and I need 2 of these, so that I get 1 Fe and 2 Br. Iron 2 bromide and iron 3 bromide are going to be different. Okay, so I better cut that and paste that onto an empty page because I'm running out of space here. We're nearly the end of this lecture tutorial actually, so I'll try and wrap it up very soon instead of dragging it on. But yeah, I mean, I've gone through quite a lot of examples. You will have a lot more examples from your own textbook, from your own classwork and homework, and of course from whatever other things that you can come up with from the name itself. Yeah, this is IDE. The IDE refers to the atom forming the ion, so it's P3 minus because it's a group 5 element with 5 valence electron. You want to go to a fully filled outer shell, so bring down the charges and then think about the lowest common multiple, which is basically cross multiplying the value on the charges, which are 2. The value on the charge is 3. This is a number. It means I need 3 of the calcium 2 plus in order to balance out the charges of P2 of the 3 minus, so that I'll get 3 of the calcium, and I need 2 of the PO4, oops, sorry, not 3, but 2 of the PO4 3 minus. I hope that makes sense there. The next one, second to last, you have Na plus. Hydrogen carbonate was in the table I given you. HCO3, not 2 minus, but this is a -1. This is actually known as sodium bicarbonate, okay, the one that people use for baking. +1 -1, I hope without me doing, I'll just write the formula straight away. They do get cancelled out by having 1 of each. Alright, cobalt 3 oxide. So you have cobalt 3 plus. Cobalt is in the first row of the transition element. Transition elements are transition metals. They are found in the middle block of the periodic table. Oxide, O2 minus. +3 minus 2 is the same as what we've done before for chromium 3 oxide. Chromium 3 oxide is also the same as this aluminium oxide, which is your case study. You will learn more about this in a future topic. Anyway, bring down the value. Okay, cross multiply it, bring down the value. What does that mean? You need 2 of the cobalt 3 plus and you need 3 of the O2 minus, so that your formula is going to be cobalt 3 plus, you need 2 of it, and then O2 minus, you need 3 of it. So be very careful about writing this. I purposely choose this because you need to write very carefully. Big C, small o, and then big O, small 3. The small o refers, well, it's part of the cobalt, it's not big O because it's not oxygen. Okay, So that's it for this lecture tutorial, and this completes the chemical formula lecture tutorials, and in the next lecture tutorial I'll cover something else. Thank you for watching, and don't forget to subscribe to the channel, click the button on the bottom right, and share the channel widely with all your friends, chat and study group, your juniors and your seniors from school, whomever else you think these kind of videos on my channel are useful for. And yeah, follow me at ptet.chemistry. That is ptet.chemistry on Instagram, Facebook and Twitter to get connected, and yeah, send in your messages or whatever. Okay, all right, see you in the next tutorial video. Thank you for watching.